Hey, 7th period. Okay, so you've got your note sheet in front of you. We're going to do just a couple quick examples, and then you'll pause the video and try some other problems. You guys should like this because it's kind of a review of some older stuff. So, we're just distributing, all right? But in this problem, we're going to distribute the 4x squared, or negative 4x squared, to the 5x and to the negative 2. So when I do that, negative 4x squared times 5x, well, I can multiply the number parts together. Negative 4 times 5 gives me negative 20. And then the x squared times the x gives me x to the third. Remember, add the exponents. It's like x to the first. Okay, and then I'll do the same to the minus 2 part. So negative 4x squared times negative 2 gives me positive 8x squared. And that's it. That's my answer. We're not solving, we're just simplifying. There's nothing to solve for. There's no equal sign. Okay? All right, so let's try example B. All right, so there, example B. Now, oh, look, there's 3 things in the parentheses. That's okay. We just got to distribute 3 times. Okay? So the 2a to the 5th times negative 3a cubed. That's negative 6a to the 8th. So make sure you're copying this down as we go here. And then, yeah, a to the 8th, because it's a to the 5th, and a to the 3rd. That gives me a total of 8 a's. All right, and then we'll do 2a to the 5th times a squared. That's positive, so plus 2a to the 7th. And then one more time, we'll do 2a to the 5th times 5b squared. And that's plus, again, 10. Wait, a and b, I can't multiply those together. So it's just 10, a to the 5th, b to the 2nd. You don't try to combine them or anything, you just write them as a multiplication problem. And that's my answer. So, pause the video, and I want you to do problems 1, 2, 3, and 4 with your groups. Okay, here are the answers to 1 through 4. So pause the video again and just check your 4 answers real quick. Okay, we're going to move on to the back now. Again, make sure you're asking your teammates if you have questions, helping each other out. So let's look at example C. So now we're not distributing anymore, we're adding, right? It says add this first thing to this second thing. Okay, we'll add this first 3x squared minus 5x plus 8 to 6x squared plus 8x minus 13. So I need you to really copy this down carefully, exactly what I do here. We're going to do these problems in a certain way, so when they get harder, right, we're doing them all the same way, and I think it'll help out. So what we do is we copy the first one down. We go 3x squared minus 5x plus 8. And what we need to do is line up the like terms below it. Okay, we're adding, so I'm going to go plus, and then 6x squared lines up under the 3x squared. 8x lines up under the negative 5x, and I just keep the plus there. And then minus 13 lines up under the minus 8, or under the plus 8. So I lined up all my like terms. The x squareds, the x's, and then the constants. And now I'm just going to add my like terms together. So 3x squared plus 6x squared makes 9x squared. Negative 5x plus 8x equals plus 3x. And 8 plus negative 13 is minus 5. I don't have any more like terms. That's my final answer. Okay, let's take a look at the next problem. Example D. Now it's a subtraction problem. So we're subtracting. It makes it a little bit harder. The other thing that's weird about this problem, look at the first one. It's got 3 terms, 5a squared minus 18a plus 6. But then the second one only has 2 terms, a squared and plus 5. So the second one is really missing the a. So we're going to have to do something about that. So same thing, we're going to line them up. So I'm going to rewrite 5a squared minus 18a plus 6. And I'm going to write minus. Whenever you subtract, it's good to use parentheses because we're really subtracting the whole thing. Okay, I'm going to line up my like terms. 12a squared goes under the a squared. I don't have an a, so I'm just going to kind of leave that spot blank, and then plus 5. Okay. One thing we can do, instead of leaving that blank, what we'll say is there's 0 a's that we're adding, so we'll go plus 0a. There aren't any a's, so we could call it 0a. Now we're subtracting, and this is a really important part. You've got to say this out loud to yourself. Okay, 5a squared minus 12a squared. You say it in your head, and you go and do that problem. 5a squared minus 12a squared is negative 7a squared. Make sure you slow down so that you don't make any silly math mistakes. Then we go to the next one. Negative 18a minus 0a. Well, that's easy. It's still negative 18a. And then 6 minus 5. 6 minus 5 is 1. So plus 1. There's my answer. Okay. Now you're going to try out the next 4 problems. Pause the video. Okay, here are your answers for 5 through 8. So one thing I want to point out, like for example in number 6, look here, we've got negative 2a minus negative 5a. The minus negative becomes plus. So really you should then say negative 2a plus 5a, which gives me positive 3a. So that's why that answer is that. Okay, so pause it so you can check your other answers, and then we'll move on to your binders, page 109. Alright, so you should be on page 109 in your binder. I don't want this video to be too much longer, and there's a lot of examples on these pages, so it's just kind of a little talk about the vocab. So a monomial, you maybe have heard of that before. Well, mono means one, so a monomial is just, it's one term. Okay, and it's got numbers and variables. The one thing it can't have is it can't be divided by a variable. The variables are never in the bottom, so that's why these 2 examples in the top right are not monomials. But everything else that's just one term is a monomial, right? And so, I mean, monomials are what we've kind of just known as terms. Okay, so then a polynomial, well, poly means many, so a polynomial has many terms. Okay, and we have a couple special ones. All right, a bicycle is something with 2 wheels, so a binomial has 2 terms. And then a trinomial, like a tricycle has 3 wheels, a trinomial has 3 terms. So you can look at the examples on this page. And then, like we said a second ago, a polynomial has many terms. Not a specific number, okay, but more than 2 or 3. Well, a binomial is a type of polynomial, okay? But a polynomial is just a non-specific. It's got any number of terms. All right, flip the page. So we have a measure called the degree of a monomial, and it's kind of like, the degree of temperature is how we measure temperature. So the degree of a monomial is kind of a measure of the strength. So look at these 4 examples at the top. All right, the degree is the total number of exponents in the term. So here, 8x cubed, the total number of exponent is 3. So the degree is 3. And on the right here, 5xy squared z. Well, the x has 1 as its exponent, the y has 2, the z has 1. So that's a total of 1, 2, 3, 4. That's why the degree is 4 there. Then we have this third one here, bottom left. Negative 81 doesn't have any exponents, so its degree is 0. And the bottom right here, a squared has 2, b to the third has 3, c has 1. So 2 and 3 and 1 make a total of 6, so the degree is 6. Okay, so we could say the degree of a monomial is the total number of exponents. Okay, so that's the degree of one single term. But if we want to talk about the degree of a polynomial as a whole, when it has a bunch of terms, okay, It's the degree of the biggest degree of any monomial. So let's look at these examples. Here's the polynomial. 5d squared plus 6c squared d squared minus 4 plus 2c cubed. Looks kind of confusing, okay? But let's break it down. How many terms are there? 1, 2, 3, 4. So there's 4 terms. Okay. Let's list off the degree of each term. So the first one is d squared. That's the degree of 2. Then c squared d squared is 2 and 2 is 4. We're adding up the exponents right there. Negative 4 has degree 0 because there's no exponent there. And then c to the third has degree 3. Well, what's the biggest number there? It's a 4. So we say the degree of the polynomial is 4 because it's the biggest degree of one of the monomials. Okay. Look at the bottom example. There's 1, 2, 3 terms. The degrees of each are 4 for the first one, because 3 and 1. 3 and 5 make 8 for the middle term, and then y to the fifth, so degree 5. So the degree of the polynomial is the biggest one, 8. Okay. All right, we use the degree to name the polynomials, and you've heard some of these names before. So we're just going to fill these in here real quick. Okay, so the degree of a polynomial where the first one is negative 14. The degree is 0. We've called that something before. You've heard this before. It's a constant. Constant. Oh, let's try that again. Constant. You spell that C-O-N-S-T-A-N-T. Okay, then the second one here, x to the first. So it's degree 1. We call that linear. If it's degree 2, okay, so let's look at x squared minus 3x plus 1. It's a trinomial. It has 3 terms, right? And the biggest degree is 2. So we look at that one. The degree is 2. And when it's degree 2, we call it quadratic. Q-U-A-D-R-A-T-I-C. Quadratic. The next one has degree 3. And degree 3 is cubic. Degree 4, you can see the pattern now, we're counting up by ones. Degree 4 we call quartic. Kind of like quarter, quartic. And degree 5 has kind of a funny sounding name. It's quintic. Q-U-I-N-T-I-C. Quintic. Okay, almost done. Just flip to the next page real quick. We're on page 111. I'm going to look at a couple of these problems in 5 through 14. It says, name each polynomial based on the degree and the number of terms. So, for example, number 5 here, number 5 has 2 terms, so it's a binomial, and its degree is 2. So, we call this a degree 2 was quadratic. So we call it quadratic binomial. We usually say the degree word first, so constant, linear, quadratic, cubic. And then we say the number of terms second. Binomial, trinomial, monomial. So look at number 7. There's 3 terms, so it's going to be a trinomial. And what's its degree? Well, look at that biggest exponent is 5, so that was quintic. So this is a quintic trinomial. Let's see. That should be good. Maybe try out a couple more of these, but now you can go ahead and work on your homework. Email me if you have any questions. Have a great weekend. Thanks, guys. Bye.